Workbook and slides, physics, mechanics, projectiles is next. Oop. Okay. Right, we'll get started now. Does anybody know this word actually, projectiles? Does anybody know this word? No? Nobody knows this word, really? Interesting. Thought maybe one person might know. No?
Something launching into the air.
Yeah, that's it. Yeah, that's it. So, projectiles, if you can write that down, please. Okay, got that? Yep. So what exactly is a projectile? So a projectile, now you actually said it's like something that moves in the air. A projectile is an object that travels through space with only the force of gravity acting on it. So it's something that moves in space, and there's only one force, it's gravity. It generally, okay, so for definition, really you just need the first sentence here, okay? But just to explain a little bit more. So, if I throw something, that's a projectile. If I kick a football, that's a projectile. Yeah. Generally, but not always, generally, it travels along a parabolic path. Now, what does that mean, parabolic? Maybe you did this word in maths class. No? Never seen it before? Yeah? What do you think it is? Yeah, where do you see it in maths?
Graph?
Yeah, which graph though? Have you done quadratic graphs?
Yeah.
X squared graphs? Yeah? And you know its shape?
Yeah.
Yeah, that's called a parabolic shape. So what I'm saying is when you throw something, it moves on a parabolic path. It has this curve shape to it. And here's a good picture of it, this parabolic. Okay, so I thought you knew this word, so you maybe should write this word down, parabolic. It means this shape. Yeah. Since you didn't know it, you should write it down. Well, what would you call this shape if you didn't know this word? Okay. Yeah, curve is very general, because anything, this could be a curve, Okay, continue. So this is a projectile. You can see it's a projectile, and once the bicycle leaves the ground, so once the bicycle is off the ground, the person has no real control. The only force is the gravity force. Now, okay, that's not really true. There's some air force, but mostly it's just the gravity force acting down. Now, Superman is not a projectile. So what's different here and here?
He's going up. Straight up.
Yeah, so what precisely makes his movement in space not a projectile? I mean, that's a projectile.
Everywhere.
Yeah, so Superman's not a projectile because he travels whatever way he wants to travel. He's not subject to only gravity. Okay, he can deliver an upward force. He can have an upward force. Okay, so now let's start talking about the physics here. So It's unfortunate. It seems like it's a bad use of words because we're talking about dimension at the start of the semester, length, mass and time, but also in physics. In maths you call this an axis, okay? But yeah, in physics you can call it an axis as well, but you can also call it a dimension. Okay, so if I say dimension, I could also mean axis. So here I actually mean axis. So there's some points to know, but you should write these down. The first one is that the dimensions are independent. I'll explain what that means now in a moment. Well, I wonder if anyone thinks they know what I mean when I say the dimensions are independent. Well, what could I mean by that? What do you think? What could I mean? Any ideas? Don't be shy. What does the word independent mean? You know? If you have two things which are independent, what are you trying to say? You're like a separate, yeah. So obviously they're separate. They're two different things. So what could I mean when I say independent? Well, this is what I'm. Yeah.
The one does not rely on the other.
That's it. Yeah. That there's no effect between them. So I'll give you an example. If I'm standing here and I jump up and down, that will not affect me moving left or right. Okay? I can't move left and right if I jump up and down. And I can't move up and down if I move left and right. So they're independent. They don't have an effect on each other. That's what I mean. Next point, and this is obvious, gravity is only on the y-axis. But I think that is obvious to everybody. Gravity is not in the x, it's only in the y. Yeah? Okay. You got that? Okay. Next point. And again, there's no acceleration in the x. Why is there no acceleration in the x? Why do we think?
Because there's no gravity?
Yeah. Yeah, there's no gravity. So there's no acceleration because there's no force in the x. Make sense? Yeah. And vectors can be used to resolve projectiles into xy components. So what I mean by that is, if you have something here, let's say this is 10 meters per second and this is 30 degrees. You learnt in your vector lesson how to calculate this and how to calculate this. What's this side? Yeah, 10 cos 30 and this one is 10 sine 30. So you can get the x vector and the y vector using what you learned. Okay, so maybe you could just say vectors can be resolved if you don't want to write the whole sentence. Oh, and there's another word that means axis and dimension, component. So now you have three words. You have you can call it an axis, you can call it a dimension, or you can call it a component. Are there more words? Yes. You might actually know them from maths class. Does anyone know another word? Axis, dimension, component. Think about maths class, you might know another word for this and this. Axis, dimension, component. Begins with a C. CO. Coordinate. Coordinate, yeah. Okay, continue. Yeah. Next point. Projectiles have no vertical speed at their maximum height. So what I mean by that is, picture I throw this up in the air. Now, I think we saw this already, but if I throw this up in the air, it slower, stops, and then faster. So when it's at its maximum, it has no vertical speed. Okay. Do you understand? Yeah. I think we saw something like that last time, didn't we?
Yeah.
Yeah. Got that? Happy? Yeah. I got more. Oh yeah. So I've said this a few times now, but it's worth saying again. Remember, S is position, not distance. And again, we saw that last time when we had the S equals -1. Do you remember that? Yeah. So remember, S is position, not distance.
So if a thing goes to maximum height, does it mean it doesn't have any speed?
Yeah, at the point at the top, it has no speed. Yeah. Okay. So the last point is worth restating. For example, a ball that's kicked. Now you really have to think about this. If I kick a ball, I'm standing here. I kick the ball, it goes up in the air and lands here. It travels. It has two dimensions. It travels. It travels vertically. It travels horizontally. Okay, so it goes up and down. So we have an SX and we have an SY. So what is the SY here when it hits the ground? What is it? Not quite X, I'm afraid. No. It's 0. Because there's no height on the ground. Now the SX will be X. It will be this. Yeah. So the ball goes like this. The SX will be this distance, which we can call X, and the SY is 0. Okay. So if I kick a ball at the end of the flight, the SY is 0. And well, I've shown you already. Yeah. Is that okay now? Does that make sense? Okay. So look. Let's do our first example. So I'll do this. I just want you to draw the picture. Actually, just draw the picture for this story, and I'll do it. Okie dokie? You drew a picture? Yeah, and just draw the path in as well. Do you know what I mean? Draw like the curve. Yeah, so you know, something like this. So here is the ground. What is it, a football? Oh, don't know what it is. 100 meters per second and 30 degrees. And it will go like this, go up and lands here. And we're also interested in this point here. And this one here is 100 cos 30 meters per second. And this one here, 100 sine 30. Yeah, that's the picture. Drawing the picture is very important because it's a good start to solving the problem. Yeah. Right, so let's begin. What's my first question? So my first question is, what is the time of flight? Now that expression, time of flight, what time is that? That's the time to go from the start to the end. That's called the time of flight. Or sometimes you just write it TOF for short, time of flight. So we have a choice because we have two dimensions here. we have an x dimension and we have a y dimension. Which do you think I need to look at if I want to figure out the time? Should I be looking at the x or should I be looking at the y? You had a 50-50 chance and it was the other one, I'm sorry to tell you, but thank you for trying. Now the reason now, so why do we look at the y? Because what we really want to know is how long it takes the ball to go up and come back down. So this is how my mechanics teacher explained it. I thought it was a good explanation if you want to picture this, okay? So picture you have your ball moving in the air. Like this. And imagine there's a little laser, a little light. It shoots a little laser out from here and here. You know, a little red dot. So if you look at the ground, you will see a dot moving across the ground. You can see a little dot moving across the ground. And if you look at the wall, you'll see a little dot. What will happen to the dot? It'll go up. Yeah, and then it'll stop here, which means the ball is actually here. And then it will fall back down. Okay? You actually want to look here because the time it takes the dot to go up and back down is the same time it will take the ball to do this. So we just need to focus on the y direction. Okay, so we look in the y-axis.
Isn't it
It is, but the problem is with the x is we don't know this distance. That's the problem. If we did know the distance, we could use the x, because it would be the same time. Yeah. Okay, so in the y-axis, what's the u? How big is the u? What is it? 100? Nope. Thought you had it. Now remember, we're looking only in the y. We need to imagine only the y exists. That's it. 100 sine 30. Okay? What's the v? Think about the dot going up, down. We don't know. Because we don't know how fast it's going when it's coming down. The a we do know. What's that?
9.81.
Yeah, minus 9.81 minus g. Okay. The t, do we know? No. In fact, the t is what we want. And finally, now think very carefully, what's the s? Not 100. What's 0? No. Why is it 0? Yeah. Why is it 0? Projectile demonstration. Why is it 0? So, watch my hands, okay? I'll do my best. So, the rubber actually will make a nice ball, projectile. This is the wall, we can picture. So, here it is, it's moving like this. Okay, so I want you to picture as this moves, there's like a little light here that goes up and down. Okay, so tell me what's happening to this vertical here. It's increasing, and then at this moment, it's maximum, and then it decreases. So if you could look at this, you would see the vertical goes up, stops, comes down. So here the u must be the 100 sine, because that's the vertical. Okay. The a is minus 9.81 because it's gravity, and the s is 0 because at the end you're back at the start. There's no displacement. You're back at the start, so the s has to be 0. Now I have 3 things here. So could I find the t? I could find the t. What formula will give me the t? How could I get the t? What formula? Let's see. S equals ut plus a half at squared. Okay, so let's figure that out. So S equals u t plus a half a, that's 4.905 t squared. What's 100 sine 30, please? Is that 50?
Yeah.
50. So you have 0 equals 50t minus 4.905 t squared. What type of equation is this? If you have 4.905 t squared minus 50t equals 0, quadratic. Now this quadratic can be solved actually quite easily, because what you can do is you can factor out the t. So you have t, 4.905t minus 50. So we get two answers for t. The first one is 0, or 50 over 4.905, which I think is about 10 seconds, roughly. What is it exactly, actually? 50 over 4.905, please.
10.19.
10.19 seconds. Now, there's two answers. Why did we get that first answer? Like, it's kind of right. You know, t could be 0. Like, what does that mean?
Start at the start.
Yeah. When t is 0, it's at the start, which is consistent with needing this. But obviously that's not the one that we want to take. We don't want to take the start, we want the time at the end. So we reject this answer and take this answer. Yeah? Oh, sorry, you need your projectile back. There's two lessons in semester 1 that really confuse students, and this is one of the lessons. Okie dokie, you got that? Yeah? Siva? Nearly, yeah. Yeah?
Wait.
Yeah.
What is 4.909?
Oh, that's a half G.
Why?
Oh, you know the formula, UT plus a half A. Yeah. So G is, this one is 9.81, isn't it? So half of it is 4.905. Okay, continue? Yep. So the next part, what is the range? Now the range is this distance. That's called the range. Okay, so should we look at x-axis or y-axis? X-axis, yeah. Now this is the thing about the x-axis. There's no acceleration. So in the x-axis you can actually use your distance, speed, time triangle. Okay? So what is the distance? Do we know the distance? No. That's what we want, isn't it? So we'll call that r. Speed. Do we know the speed in the x-axis? We do. What is it? 100 cos 30. Okay? And do we know the time? We do. What's the time of flight? 10.19. So using the triangle, we can say the range is 10 cos 30 times 10.19. What's that, like about 70 meters about?
100.
Oh, sorry, thank you. 100 cos 30, thank you. So about 700 meters, is it about? 707? No, I'm going to say 710 meters. That's my answer. Let's see. Was I close?
882.
I wasn't that close. 882. Yeah. Yeah, it's okay. Right, and the last part of this question is, what is the maximum height? So, if I just go to the side here, the maximum height is this distance. Should I look at x or y? Y-axis, okay. So what's the u? 100 sine 30, which is actually 50. What's the v? 0. Why? At maximum height it's 0. What's the a? Yeah, minus g, minus 9.81. Now be very careful, what's the t? We don't know. Because the previous t that we got was the time to go up and down. So we don't know. And the s we don't know, but that's actually the thing that we want. Okay, so what formula gives me the s here? V squared? Yeah? V squared equals u squared plus 2a s. I think I did that right in my head. This is 2a, I believe. So the s, which is the maximum height, that's equal to 2500 divided by 19.62. And that's the answer. $27?
127.
What is it?
127.
Oh goodness, it's way off. 127 meters. 27, that was ridiculous. I meant to say 127. Okie dokie? Yeah. Yeah. Continue. So, that's our first projectile example. Right. Here's a little bit of a harder one. So again, I want you to read and draw the picture. See if you can draw the picture. Okay, we have pictures. Not quite. Siva, let's have a look at your picture. What did you end up drawing? Yeah, similar now to math, but not. So yours. Yeah, everybody's kind of doing the same thing, but it's not quite right. Let me draw it for you, okay? Right. There now. Okay. How far away is the apartment building? 25 meters. So that means here to here, 25 meters. Okay. Now, the ball or the stone leaves her hand at a height, I think I said, of 1 meter, didn't I? Yeah. At an angle of 60 and a speed of, was that right, 60? Yeah, and at speed of 25 meters per second. So it goes like this. Okay. That's what I wanted to see. So we understand the situation? Nobody drew the stick man. Nobody drew the stick man. That's important, you know.
I drew it.
You did? That's a tiny stick person. Okay, so let's do the calculation now. So what did I want first? The time of flight. The time of flight. So let's see. Here, that is 25 cos 60. Yeah? Whoa. And then this way, 25 sine 60. Okay. Should I look at the x or should I look at the y to get the time? Yeah, we could actually do both. We could actually do both here. So in this case, I'll look at the x-axis. So if we look at the x-axis using our triangle, what's the distance in the x? What's the distance? 25. What's the speed? 25 cos 60. And what's the time? We don't know. That's what we want. So the time would be 25 over 25 cos 60, which I think is 2 seconds. Half or 2? Okay. You worried me. Is that okay for the x? Yeah? Now, let's have a look at the next question. What is the height here? So, I want to know what is this height here of the building. Okay, so obviously I have to look at the y-axis. Okay? Let's get our y info in the y-axis. Right, so what's the u here?
1.
The u? Yeah. Not your, you might be thinking of something else. 25 sine 60. Okay. The v? We don't know. The a? Minus g, yeah. The t? The t we do know. It's 2 seconds to hit the building. And the s we don't know. That is what we want. Alright, so let's see. What would be the best formula to get s? S equals ut? Yeah? The height, well, firstly, the s equals u t plus a half a t squared.
$18.68.
18.68 meters then. Yeah? No? Yes? No? No? Uh-oh. What did you get?
5.38.
Oh, that's quite different.
Minus.
Minus?
23.9.
Can you hand me your calculator? Thank you. Well, I know minus is definitely a problem.
Yeah, I think I did 50 instead of 60. 23.6?
23.68. Thank you. Is that the answer? No. It's not the answer. The answer is 24.68. Because that S was only from here to here. That S. So you have to add on 1 extra meter. So the height is actually 24.7 meters. Can you see why? Because if we go back to the picture here, this is the x-axis and this is the y-axis. So your number needs an extra meter if you're measuring from the graph. Is that okay? Yeah. Right. I think there's one more. Yeah. So I'm going to let you try this, but I'll do it a bit differently. I'll draw the picture for you, okay? Tom and Louise drive their car off the side of a cliff at the end of the movie. The cliff was 400 meters high and the car was traveling at 36. So what you have is this. This, I said, is 400 meters. And here's the car here. There's 2 of them in it. Okay, and the car is going this way at 36 meters per second. So we can kind of see what's going to happen to them. Right, that's a fire. Okay. So my question is time of flight. I want the time, I want the range, I want the velocity when the car hits the ground, so that's called the impact, and I want the speed of the car. Okay, so that's the picture. Looks like this. You understand the picture? 400 meters here, 36 here. Yeah. Can I go to the questions? I can put up the questions? Yeah, okay. So here's the questions now to try. Okay. Let's get a start together doing it. So, did you manage to get a time? No? No problem. Because it's a little bit different, this one. Okay. Should I look at X or Y to get the time? Let's do it together. Y. Okay. Right. Now, U is... Go on, Kim. What are you thinking? That is not right. 0. Sorry. Why is it 0? Matt. Yeah. There's nothing here. It's only horizontal. There is no vertical. Because the car is moving on the ground. You know, it's not like the car went up a ramp. You know, it's just along the ground. So there's actually no vertical. Okay, fine. V, don't know. A is minus G. T, we don't know. And S, what's S? Ah, math. It is not 400. Minus 400. Minus 400. And that makes a big difference. Yeah. Okay, what will give me the T? What formula? S equals UT plus a half A T squared. So that means T will equal the square root of 400 over 4.905. Okay, what's that, please, when you're ready?
.07.
4.07 seconds.
9.
Oh, that sounds a bit better. What, did you square root?
Mm-hmm.
Oh, what happened to you? 9 point...
03.
Okay.
Okay, that's fine.
Okay, next question. Right, I want the range. So how can I get the range here? What should I look at, the X or the Y? I should look at the X, shouldn't I? So X-axis. Right, so what's the distance? We don't know. We'll call it R. What's the speed in the X? What's the speed in the X? 36, yeah? Distance, and what's the time? 9.03. So the range will be 36 times 9.03.
.08.
325 meters then. Yeah? Okay, next. What is the velocity at impact? Okay, so let me just zoom in here. I want to know how fast the car is going when it hits the ground. So I want to know what the Vx is and what the Vy is. So you have to look at both. Now, the good news. We actually know one of them already. Which one do we already know? The X or the Y? Yeah. It's 36. But we don't know the Y. So we have to use our UVATS in the Y-axis again. Okay, so the U, what's the U in the Y-axis? 0. The V we don't know. because that's what we want. The A we do know, the T we do know, and the S we do know. So I can get the V easily by just saying V is U plus 8T, which will be 0 minus 9.81 times 9.03. So what's that, please? Be like 85 or something. What is it? 18? Oh, 88.6 meters per second. So this is the velocity here. So what happens is the car hits the ground at an angle. You know what I mean? Like it hits it at an angle. So this direction it's going 36 meters, and downwards is going 88 when it hits the ground. If you're in the car, which is more important when you hit the ground, the 36 or the 88? Yeah, much more important. The 36 isn't a problem. The 88 that's the problem. When you hit the ground. Yeah, that's definitely the problem. And the last thing I want here is the speed when it hits the ground. Now how can I get that? Do you remember what I said the speed was? How you can get the speed from the velocity? Say again? Don't actually need the time. What you can do, if you remember, speed is the magnitude of the velocity. So here speed is square root 36 squared plus 88.6 squared. That's how fast it's going when it hits the ground. That's its speed in the air. Now, there is another way to get speed, but you can't do it here. What's the speed here?
95.6.
Now there is another way to get average speed or speed, but you would need to know things like the distance. And you actually don't know the distance because the distance is this. And you don't actually know that length. You can only know this length and this length. You don't actually know this length. So, anyways, do you remember me saying the speed is the magnitude of velocity? No? Yes? It's gone? You do or don't remember me saying this? You don't look like you remember me saying this. I said this in one of the vector lessons. It was a definition. I'm sure you'll find it in your notes. Yeah? Okay. So look, I'll just put it like this, look. If this hits into the ground, okay, if it goes this way with 3 and this way with 4, then it smashes its face into the ground at 5. Okay? So this is the problem, of course, but you would say it hits the ground at 5, which is the same as saying it hits it horizontally at 3 and vertically at 4. You know, hits at speed 5 meters per second is the same as saying hits x at 3 and y at 4 meters per second. You know, but we call this a velocity and we call this a speed. So this with the x and the y is called the velocity, and this one is called the speed. Yeah? So look, okay, that's that. I'll give you a couple of minutes to try these for a few minutes, and then we'll go on to the next lesson, which isn't as hard. So try your projectile questions for about 5 minutes.